Today we're going to power up the PICqueno32 board for the first time and also program the firmware into it. Last time we had to replace the PIC32 chip because I used the wrong version. The power-up test is just the first time we apply power to the board. We want to make sure that there's no shorts, that nothing pops, no smoke comes out, anything like that. Now I always do a power-up test using the Bus Pirate. The Bus Pirate has onboard 3 and 5 volt regulators. They have overcurrent protection, over temperature protection, stuff like that. And in the program, when you turn it on with the software, which I'll show you in a minute, if there's a short, if the voltage doesn't come up, then the Bus Pirate will detect it and turn off the power supplies automatically. So that way, even if there's a short in the circuit board, the power is only applied to it for a short amount of time. So I've got the 5 volts and ground brought out to 1-to-1 female connectors here. These are available at Seed for a couple bucks for 100. I love them. Okay, and we're just going to find somewhere to tap in here and add power. On this board I'm going to use ground at the programming header, and then I'll connect 5 volts to this pin here, which is the voltage select pin. And then we'll switch over to the computer. And now here we're in the Bus Pirate terminal. Get info and get the version. And we need to go to a mode in order to use the power supplies. We'll just go to the first mode, 1 wire. And now the power up command is just capital W, and it will power up the board. Power supply is on. It didn't report a problem. The light came on the PICqueno, so that's good. We'll hit V to get a voltage report. You can see that the 5 volts is coming up as 4.83. That's acceptable. There's a heavy load and it's coming from USB, which isn't exact anyways, so that's to be expected. So we can reasonably assume now that there's no shorts on the PICqueno board. So we can connect it to USB, see if the FTDI chip enumerates, and then go ahead and program the bootloader into it and try it out with the software. Okay, now we're ready for the first USB test. We're going to plug in the USB cable, see if it powers up. On our board, it doesn't automatically select between USB and external power yet, so we need to put a jumper here over the bypass pin for USB power and then plug it in. If all goes well, boom, so it connected, it enumerated, and I can see it as COM32 on the computer. Now we've got the PIC programmer connected to the PICqueno development board, and we'll switch over to the screen and take a look at MPLab. This is the software Microchip uses with their programmers and with their compilers. We're just going to use it to program right now. So we'll go to Programmer, Connect. We found the chip, so that looks good. And now we'll import the firmware. Okay, now it should be as easy as saying program. And now we'll try to connect it to the IDE. One thing we need to check are these pins. Without a jumper, the automatic reset won't work. And then we won't be able to program directly from the Arduino IDE. So we put a jumper over there, and we'll switch over to the computer, and we just open the most basic Blink example. Set up the tools for the ChipKIT 32 and selected our serial port, which is COM32. We've got the basic demo here, nothing special, we're not going to make any changes at all. Just go ahead and compile it. Okay, and then hopefully we can upload it to the board without doing anything else. Nice. It seems to have worked, and the blink has slowed down, so we can assume our program's in there. Well, test 1 of the PICqueno32 is done. A little more extensive testing, finished populating the boards, testing everything out, and we'll either be ready for another revision or to put it in production.